I'm going to go over the encrypt and decrypt and object-oriented programming problem. And so I thought it would be a good one to go over because so many of you struggled with it. So I am going to do a few things differently just to be in the spirit of OOP. And the first thing I'm going to do is I'm going to rewrite a text class called text.io, and that's going to be for the purpose of read, write, append to a external text file, since we'll be working with a text file in this application. You'll notice I already have 3 files created. They're text files only. I have a plain text file, and in the plain text file I have a message. Let's encrypt this message in OOP. I have an encrypt text file, and there's nothing there, and a decrypt file, nothing there. The goal is going to be to take what was in the plain text file, encrypt it into the encrypt.txt file, and then decrypt it into the decrypt text file. So that's why these 3 files exist. Alright, so the very first thing I'm going to do, having done this part, is I'm going to create a new file called, I'm just going to call this text, let's see, text.io, input IO for input output, and it's going to be, I'm going to go ahead and list it as objects. So these will be objects of this class. It's going to be a Python file, so .py extension, and here we go. So the very first thing you should do is do your quotations, so you can do a message in the middle here, and the message that I'm going to put is going to be read, write, append objects. There you go. Okay. So yes, you could do the read, write, and append inside of a different object, or possibly even in the main function. We actually aren't going to be using functions. We'll be using class methods on this one. And so, but like I said, to write in the spirit of OOP, I decided to go ahead and create an entire class that we'll be accessing and passing it arguments in order to either read, write, or append our file. Okay, so the very first thing I need to do is create the class text.io. Okay, so on lines 4 through 8, we have the code for the class, and this is the actual, the class is text.io, and the on lines 5 through 8 we have the constructor. On line 5 you can see that we're going to take 3 arguments. We're going to take text_file. That's going to be the name of the file that we're either writing to, reading from, or appending to. Operation is the second parameter. Operation is going to be what it is we're going to do, read, write, or append. And then text is the last file, or excuse me, parameter, and that is the that's going to be what it is we're doing, or the actual text that we're encoding or whatever. So text. You'll also notice the constructor is done in the same format that I've been showing you already, and so let's make it a space here. And so here, and I'm going to leave this space here just so that it's easy to read, even though PyCharm wants me to close up these spaces. I'm not going to. So in any case, we have our self.text_file, self.operation, self.text, and these are the properties for the class. And we're going to assign those properties to the parameters, and that's why you see the equal sign. So self.text_file is going to be assigned the value of text_file that's passed as a parameter, and the same for the next 2 parameters also. All right. So the next thing we need to do is we're just going to set this in a simple try except statement, and in there we're going to be using an if-else statement. We could use, well, I was thinking about a switch case statement, but I sometimes forget we can't do switch case statements in Python. So we're stuck with an if-else statement, and that's fine. We'll do that. So, one moment. I went ahead and wrote the function that has the class. So here we have our class io_text. You can see that it's passed self, and of course remember self means that it's going to construct itself when it's called. That's all that means. Alright, so then we have our text file, and the text file we're going to say is going to open, so whatever is opened in this text file is going to be assigned to text file. So we'll take open, and we're going to pass the parameters self.textFile and self.operation. We need those two right off the bat we need to know what is the text file we're working with and what is the operation we're going to be doing. You'll notice on line 12 we have a variable called message. We assigned it a empty string value, and that's because we don't know what we're doing with it yet. Okay, lines 14 through let's see, 15 through 24, embedded inside of a try except statement, we have our if-else statement. So it's actually an if else, and that's because we have these different possibilities. The first one is that we're going to pass it the W operation, which means we're going to write, and we're going to, if that's the case, we're going to write to the .text file. You can see that on line 16. On line 17, we're going to assign message to the write completed. On the elif statement, we're going to take that operation as a read. That's why we see the R parameter. And then the next one, of course, is A for append. And these are just properties of the input-output function, so not really an issue there. Okay, so the next thing is at the very end, it ends with an else statement, and that's because if it's past anything other than a WRA, we want to catch that and return the message, enter valid operation. If any of this fails, we're going to go ahead and drop it to line 25 and catch it in the exception. We're going to take that exception, name it as E, and then we're going to write to the message whatever the error is plus the string. And we're going to take that message as a string. You'll notice that it is cached as a string on line 26. It has to be cached as a string because the format of E is not going to be in string format, and we need to put it in string format in order to read it. Okay, regardless of what happens, if the code succeeds or fails, we want to finish with a finally on line 27, and that's because we've opened up the text file. We need to close it. So on line 28, follow inside of the finally, we're going to close the text file, and then lastly on line 30, we return the message. So that's it. Here's our text input-output objects. Really, there's just one object here, and that's the class input-output_text with its operations that are going to happen. If this is called and these parameters are passed, it requires these parameters to be passed, then we're going to go ahead and do these functions. Now you'll notice in the input-output_text class, or excuse me, class method, it's a class method, that you don't see the text itself. You see self text file, self operation, and that's because when we call it, we're going to pass it on these two items right here. Then the text file, whether it's going to be write or read to, whatever that is going to happen there, it's simply going to access text from the constructor that was declared up above in the actual class, and the class was constructed. So basically, you do have a little bit of inheritance going on here in this class, but not really too much. It's really just a simple class with one class method, and then some operations happening. Okay, so that's all that's going on here. This part here was not part of the assignment. Like I said, in the spirit of OOP, I decided to go ahead and write this as an object-oriented program. Okay, so having done that, now it's time to get to the meat of the assignment, and that is to actually look at some encryption. The first thing we need to do is we need to create a crypt. I'm going to call it a crypto_objects, but it's the Python file that will contain our crypto objects. So I'm just going to call it crypto_objects, and of course remember to put the extension py. It is a Python file. And now what we're going to do is we're going to be looking at a couple of different things we need to do in order to satisfy the assignment requirements, and that is to add an integer to the ASCII int value. Once that's done, we want to shift the ASCII binary to the left, whatever number of spaces that we've decided we want to shift. In addition to that, to make things a little more complicated, we're also going to add a distance parameter. So once we've encoded into ASCII binary and then shifted, then we're going to add to that shift a certain distance, and I'll go over each of these as I do them. But the first thing we need to do is we need to create the class constructor of the encrypt file. So I'm going to do that right now. The encrypt class has been created, and you'll notice that the very first thing we need to do, of course, is create the constructor. Remember, in all of these objects, we always have to create the constructor first. So our $_init__ is going to be our very first well, it's like a class method, but it's actually the constructor. And you'll notice that we have to pass as a parameter self. It's not really a parameter, it's just passing it itself, basically setting up the construction. And then we have our 3 parameters that we do need, and that's plain text, which is the plain text because this is going to be an encrypt class. So we're going to do this in different classes. The first one, of course, is encrypt. We're going to encrypt the information, so we're going to be taking in plain text, and we're going to just call it that. Remember always to self-document your parameters, your variables, your functions, your methods. They should always be named in a way that when you look at them, you know what they're doing. So the parameter plain text, comma shift. Shift, of course, is going to be our shift of how many bits we're going to shift to the left or to the right. And then our distance, how much, as an integer value, how much distance we're going to add to that shift. All right, now we have our constructor down below. Again, the usual format, self.plaintext.shift.distance. And then we're going to assign those to the parameters as they came in, plain text, shift, and distance. All right, that concludes the constructor. The very next class that we're going to build is the string encrypt. Again, it's self-documenting. It's going to encrypt the string. That's it. So you'll notice that we're passing it self. It's going to return a value BS, that stands for bit shift, bit string. And so the very next thing here we're going to do here is write this class method. All right, so now we wrote the string encrypt file, and I'll go over this. We're going to start off with an empty string that we call BS, and that stands for bit string. And we're going to have a for loop here, and that means we're going to iterate through every character in the plain text that was passed up ahead above. And so we're going to say for each character in the self.plaintext, what we want to do is we want to look for the ORD value. And so we're going to take the ORD value, and that's going to be equal to ORD, the keyword, the reserved keyword ORD. And it's going to take the character, and it's going to return the integer value for the ASCII integer value for that character. And then we're going to add to it the distance, whatever the distance was given. And so you can see here in the comments, gets the integer value and then adds a distance to the int. All right, so next you'll see that we have an if statement. And that's to handle if that we want to stay inside of the range of 1 through 127 for the number of ASCII key values on the keyboard. And so what we're going to do is say if the ORD value is greater than 127, then we're going to take distance, and we're going to do this little formula in order to handle that situation. So we're going to take 127 minus the ORD value plus 1, and that'll handle that situation for when it's greater than 127. Now the next thing we're going to do is, now by the way, this 16 through 17, it's just an extra little step. Your code will work, the encryption will work without this. This is just in case, to do a little bit extra and handle that situation when it's over greater than 127. Okay, so number 19. We're going to take the bit string value, which is empty at the moment, and we're going to add to it, concatenate, the bit shift underscore left. So here we're going to call something we haven't created yet, and that's the bit shifter underscore left. And we're going to take the ORD value and then give it a space so we can get some kind of nice output. Now this bit shifter left is the next one that we're going to create. But I wanted to create the string encrypt class first to demonstrate how we would iterate through the text that came in, how we would determine its integer value, and then add the distance to it. So that's done right there in that class method, string encrypt. Okay, so the next thing we really need to do is we need to write this bit shift left class. And so I'm going to write that. On lines 26 through 42, we have the bit shift left. And so I just used the name bit shifter underscore left, so it's self-descriptive. I'm going to call the parameter value that's going to take in is the cipher value. And that's just whatever's passed up in here when this is called right up in here. So on line 19, where we have the bit shifter left, and we're taking the ORD value, that ORD value is going to be taken as what I'm going to just call the cipher value. You could name it whatever you want. This is just what I named it. And I have a little description of what's going on here. Okay, so here we're going to need a couple of other values. We're going to be looking at the shifted string and the bit string. Now we have a while loop. The while loop is going to say, let's take this cipher value that we passed it, and if it's greater than 0, then convert it to the ASCII int to binary. And so just a nice little check to make sure it's greater than 0. Now we're going to pass it a little formula here, and this is to make sure that we get our conversion for base 2. So this right here, this lines 30 to 33, all this is doing is it's converting from base 10 to base 2. That's what this is doing. Well, binary, from decimal to binary is what is happening right there. Okay, So once we've done that, we're going to look at the bit string. We need to find the length. See if it's less than 8, then we're going to add a 0 to the front of it. And that's just so that we can always have 8 bits in our output. And so we're going to take that bit string. If it's less than 8, we add a 0 to the front of it. And that, again, just for formatting to make sure that we have enough zeros. The next thing we're going to do is we're going to take the bit string and we're going to shift it. We're going to shift it to the left. And so all we need to do is say take the bit shift and shift it. We're going to assign it. We're going to concatenate whatever the bit shift is, and we're going to start at the 0, and we're going to capture all of the elements except for the last elements, and that's what's happening right here. And so this is going to capture all elements except for the last element. And the reason is we don't want the last element. And what we're going to do here is now we're going to take the full bit string after the shift to the left. So that's going to be the SS for shift, and we're going to concatenate it with the bit shifter that we created here and add a space to it so that we can have the full string nicely formatted. And then we're going to return the full shifted string. Okay, so let me see if I explained all that properly. I'm going to increase the font size a little bit and make sure. It's been a while since I wrote this. Okay, one moment here. Okay, so this one right here is capturing only the first element of your string. So if you had a string that was 1, 2, 3, 4, it's capturing 1. Then this part here is capturing everything except for the last element of the shift of the string. So the very first element, and then everything except for the last element. And we're putting the first element in the very front, and I think that's it. Of course, adding some stuff to the beginning. And that's really it. So this is our bit shift to the left. If you're confused about this part here at all you need to do is review the section on strings and how to manipulate strings. So I feel like line 3 needs a little bit more explanation, so I'm going to try and work on that with you. Okay, so the way this works is, again, this is called string slicing. And so here, this is the shift. So whatever the shift was that we passed it up above, if we said we're going to shift it to, let's say, 2 spaces or 3 spaces, let's say shift three spaces. What this means is we're going to take that string and we're going to shift it. Let's say the shift was 3. We're going to shift it three spaces, which means we're going to capture the entire string except for the first and second index. And so if the number was 3. So if the number was 3, we're going to capture everything after the second index forward. So let's say that the numbers, let's say if there was a set of numbers, the numbers were 1, 2, 3, 4. And so let's say the shift was 3. Okay, it would skip index 0, 1, and 2. And then it would output 0, 1, and 2, and then it would output the 4th index. So it would output number 4. So if the numbers were 1, 2, 3, 4, and this number and the shift was 3, it would output 4. If the numbers were 1, 2, 3, 4, 5, it would output 4. The numbers 4 and 5. That's what this part right here does. Okay, now the second part here, what this is doing is it's capturing. Since we're starting at 0, what it's going to do is it's going to capture all of the elements except for the very last element. It's capturing the entire string except for the ending. That's what's going on here. And then in that manner, we're shifting it to the left because we're taking that we're capturing the whatever the shift is, and we're limiting the first part of it, and we're taking that and putting it to the front of everything that was on the first part of the shift. I know it's a little bit complicated. This is one of those things where you have to open up Python and just play with it. This is just string manipulation is all this is. It's string slicing. You're going to want to read the section on slicing a string. That's all I can really say. When you right here, again, right here, we're taking it. We're going to omit whatever the number of shift indexes are. So if the shift is 3, we're going to omit all the way through 3, and it will start on the item 4 moving forward. And then here, what we're doing is we're capturing the entire string. How do I put it again? It's omitting the first index and then capturing everything else. So that's what's happening here. Up to the shift, by the way. So not the whole string, just the shift. So we're starting at 0, and then we're going forward the number of shifts. So if the shift is 3, then we're going forward up 3. Okay. So, and that's how we're encoding with the shift, with the bit shifter. So the very first thing we're doing is we're converting to binary, and then we're checking to see if the binary is less than 8, so we'll add some zeros to the beginning of that string. Then the next thing we're doing is we're going to do the shift, and we're actually shifting. Then we're returning the shifted string back to wherever it was called. And in this case, that goes back up to line 19 right here, is where it's being returned. Okay, so I know that was not simple. You have to study it, you have to practice it, and again, this isn't math. Well, maybe this little part here is math, but this is really just string manipulation. And if you read this section on slicing, it's called string slicing, or slicing a list is really what it's called, but it has to do with string manipulation. You'll be fine. You just need to go over those, how that works. All right, so that was our solution. Was using string manipulation and string lists in order to do our shifting. Okay, so the next thing we need to do, we've done our bit shifter and we've done our string encrypt, is we need to create the decrypt classes. On lines 54 through 75, we have the string decrypt class, and this is basically just doing the reverse. So we're going to take our list in, and we're going to split it up individual word bits. So we're taking it into a list. We're going to throw it through a for loop and iterate through each bit string in the list. And I have a bunch of documentation to help you guys out. We're going to shift right, so we're going to reverse our shift. We're going to shift it right this time. Again, if line 61 is confusing to you at all, please review the section on list slicing. It's in the section list slicing, which has to do with string manipulation in lists. And so that's what's going on here. We're basically reversing what happened what happened right here. So it's the reverse of this is what's going on there. So of course we have our constructor as usual. We're going to take in the binary. This time we know we're taking in a binary string because we're decrypting. So it's going to be a binary string. We still need to know our distance and our shift. And then we're going to take that information. We're going to call the binary string split so we can break things into their words and pass it through the for loop. As I said, we're going to reverse the shift. Then we need to do the old, if it's less than 8, add the zeros to the fronts for consistency so we can have 8 bits. And then do the check for the 127, and then reverse the ORD. And the way we reverse the ORD, remember up here where we did the where we converted the character values to ASCII binary. Where was that at? Up in here somewhere. Right here. So where we did this right there, we need to reverse that. And so the way that we do that is we use the char reserved keyword in Python, CHR, not char, but CHR. And that's going to take our integer value and convert it back to an ASCII character, a string value. Convert from base 10 back to string value. So that's what's going on there. And concatenate it together and return it. Strip out anything that's... The dot stripped is just stripping off any extra spaces that might be on either the front end or the back end of the string. And return it. So I think it's well documented. Iterate through each bit string in the list. Shift right to reverse the shift from encryption. Add zeros to the beginning. Convert from binary to base 10. That's what this is doing. Let's see. Must fall in the range of 1 through 127. So we're looking at the ASCII values on the keyboard. Convert from base 10 to the ASCII character, so the integer value base 10, and then concatenate the bit strings together and return and strip. And that's it. We have our class decrypt object with our string decrypt class method, the algorithm here for calculating all that out, and that is it. This should work through, and I called this the crypto objects, which I think is accurate. There's nothing really complex going on here. We're not using any hashes. We're not doing any deep mathematical anything other than the conversion. And yes, I know we could there are functions in place. We could use the math function and just use what do you call it, and then just cast it to binary or cast it to to base 10. But I think it's valuable to learn how to do this stuff longhand. And so that's why I included the actual algorithm for doing the calculation. Okay, I think that's it for the crypto objects. The next thing we need to do is just actually test this thing and make sure everything works, and then debug if we need to. All right, so I created a new object here called Python encrypt underscore decrypt underscore main.py. It's a Python file. This is where we're going to access our objects and make things work. So again, remember in the plain text we have a little bit of stuff to work with. We have nothing in encrypt and nothing in decrypt. They're just two text files. We have our text input output objects. We have our crypto objects that we just created. And now we're going to use the encrypt decrypt main to actually make some things happen. Now we have our encrypt decrypt main started, what I like to call the template. So you'll notice we're encrypting we're importing some objects. From the crypto objects, we're importing encrypt as EM. We're going to import decrypt as DM, and of course, for me it stands for encrypt message and decrypt message. And then the input-output objects I'm going to call Internet of Things. No, just kidding, just IoT for text input-output. And I guess to be consistent, I probably should have put the T first, but I didn't. Okay, so here we have our main function, and we're going to now assign these variables. So plain text is going to be what's plain text, encrypt text, decrypt text. Our shift is going to be 3, and our distance is going to be 5. So now we just need to create some class methods to make some things up. Okay, so I added a bunch of things here in lines 14 through line 26. You'll see we're getting the plain text and we're going to encrypt it. So the first thing we do is we're going to create the object IoT underscore 1, and it's going to be an instance of the IoT object and pass it plain text read. There's nothing to pass it as far as a message because we're not going to give it a message, we're reading a message, but it still requires the parameter. So if you remember our IoT objects, that's simply here, and we're giving it to the IoT and we're saying we need to pass it a text file and an operation, and we're passing it this one right here. So that means all it's going to do is it's going to read from the file that was passed. Okay, so let's go back to this. So we created this instance. It's calling this object IoT, the plain text underscore file class method, passing it these parameters. And next what we're going to do is we're going to set the plain text equal to whatever's returned, and read the plain text from text message. So again, this .io text, if you recall, again it's just here. It's calling this right here, this class method on line 10. All right, so let's go back here. Now we're going to set the input-output class object variables. And so input text file, encrypted text file, operation W, text as ES for encrypted, and then here write the encrypted text to the encrypted file. So that's all that's going on here. Is we're going to pass this stuff to the file and encrypt the plain text file. And so right here, this is where all the magic happens on line 20. This is when we're passing it to the actual, you'll see EM right here, the encrypt object of that crypto object. So here's crypto objects right here, and we're passing it, we're calling it this class so we can encrypt our message right here. This whole deal, all of this is happening. And if we go back to the main, it's all happening here on one line. So we're going to take that, we're going to take it, excuse me, we're going to take the whatever the encrypted text is, and we're going to set that to ES, and that's so we can have the encrypted text. So this is happening first. We're taking it, and then we're going to get whatever was passed here. We're going to take it here now on line 20, get the encryption version of it, pass it to a variable called ES, and then we're going to set the input-output class object variables. So here we're going to say the text file is going to be encrypted text file, operation is going to be write. Now this time we're going to write. And this time the text is ES, so whatever was encrypted. And this time we're going to write the encrypted text to the encrypted text file. So we call this again using the same information, except for this time we're writing. And now we can return, and this is what this is going to do. This is going to write our file. So if we run this should work. So I just clicked the run on the encrypted decrypt up here. All of this code ran. and everything worked as it should. You'll see it, down here it says finished. I can go to the encrypted text now, and you can see that our message, which was plain text, if we go back to the plain text, was this, and I go to the encrypted text, it's now this. A nice binary string. Look at that, all encrypted. Encrypted in a very simple method. Remember, this is only shifted and then added some distance to it. So very easy to decrypt. It's not anything safe, but it's just fun, just for learning. And so if we go back to our encrypted objects, you can see the process we used. All we did was we're adding some distance, and we converted it to binary, of course, added some distance, shifted and then added distance. And it's all the entire algorithm is all here. Very, very simple. I don't think there's anything complex going on here. The encrypted part works nicely, and you can see this is all using object-oriented programming. It's all we're doing is we're setting the objects, and then we're retrieving it and just done. Now here we don't actually have to retrieve anything. Here we're just calling this command. It's going to write to the encrypted text file, and then we can just go to the text file and see that it's there. It's right here. Done. Great. Okay. So the next thing we need to do though is now we need to decrypt that message. So we need to write. We need to access the encrypted this object right here, the decrypt object, and reverse the process so that we can get our information back out. Okay, so let's go ahead and do that. Of course, the methodology and the algorithm is already written. We wrote that here. So all we really need to do is just put that section of code here to now retrieve the encrypted information. All right, so I went ahead and wrote the decrypt part here on lines 28 through 45. Again, all we do is we need to set the operation to R. We're going to be reading it. We don't need to do anything with the text file because we're working from the last text file that was set, and that text file, of course, was where it was encrypted. The binary string, get the encrypted text file, so let's return it. We're going to use the input-output IO text. Remember, we're passing it the R, so it's going to go back to that object that we wrote here and pull out the information in the encrypted text. It's going to read it and assign the value to the binary string. So so what's happening is let's go back to the encrypted objects, to the crypto objects. So actually it's here, excuse me. And so here, what we're doing is we're passing it the read parameter. So this time it's going to read, and it's this one right here. That's the information we're passing it, and it's going to return it's going to access that object, the plain text. Excuse me, not the plain text. The encrypted value here. It's going to access this, and then it's going to go to the encrypted objects and call the decrypt constructor, and then the string decrypt class method, and then reverse everything we did to it to then all return what's going to be the decrypted value. And it's going to output it right here. This is what we're going to do. Now over here, I decided to go ahead and add to the console. So here I'm going to say, okay, let's go ahead and actually output to the console whatever it is that we decrypted. So we're going to print the plain text that was decrypted and throw it here. I think that's about it. So this is going to print the plain text. It's going to print the encrypted value and the decrypted value. So let's go ahead and see what all this looks like, and we'll run it again. There it goes. Okay, so you look at the console. It says, "Let's encrypt this message." That's this first part right here, which is the it's outputting what's that? The plain text. The next one it's putting is the encrypted string. So we have our encrypted string here, and then we're looking at our decrypted string. So what happened in here when we decrypted all this information? When we can see the DS is right here. How does it look decrypted? And you can see that the decrypted message is identical to the encrypted message, so or the plain text. Plain text, so plain text, encrypted, and then decrypted, all right here. And if we look at our text files, we can look at the plain text, there it is, the encrypted text, there it is, and the decrypted text, and here it is. And you can see that it's identical. It encrypted it and decrypted it correctly. All right, so that's really it. So I think, in my opinion, the hardest part about any of this was probably in the crypto objects and following the logic of the string stuff right here, what's going on here. on these when we're shifting to the right, reverse bit shift, or shifting to the left. Because this part you have to play with in Python, and just throw a string in there and see what happens. Again, just review the chapter on it's called slice listing, or it's slicing a list, and you're going to find that in the string manipulation section of your textbook. So string manipulation and then slicing a string or slicing a list, and that's what's going on here. That's the methodology that we used to shift our bits to the right or to the left. Other than that, wrapping your mind around that part, I think the rest of this is just really straightforward. I don't see it. I mean, this part right here might be a little bit complex, converting from a decimal base 10 to a binary base 2. But again, you could just use the actual built-in function. I don't really care. I did this just so you could see the actual algorithm for doing the conversion. And that's really about it. Remember, we have to create a constructor, and then when we create our classes, we can access everything that was created in the constructor. And that is about it. I don't see anything new. I think it's a really good example of using object-oriented programming, and it's a really nice little assignment. I really like this assignment. This is one I created myself. This is not in the textbook at all. It's a really good one. I like it. I really enjoy it. Okay, so that was it. I'm going to throw this code up on the GitHub account so that you guys can have access to this code and download it and play with it yourself. All right, that's it. Happy coding.